why? It's because it's abundant and the oysters cannot move, so they cannot just move away from the hypoxic environment. And they live in the intertidal zone, which hypoxic events can sometimes occur, and they're commercially important in the shallow area. And for our experimental designs, we use 15 oysters with 3 different acclimation groups, one with high DO, low DO, and normal environment. And after 3 days, we move all of them to one tank with a hypoxic environment with a DO level less than 2. And after 3 days, we took some samples and did RNA extraction and reverse transcription and qPCR for analysis.
So our results were, at least for HSP70 gene expression, what we expected, although they weren't significant. We did see the general trend of the high DO acclimated groups showing a higher level of HSP70 after hypoxic exposure. And again, very similar, almost identical response with lower expression levels in general, but we see this trend of higher HIF expression in higher DO as compared to the lower DO acclimated individuals.
And also, as expected, we saw that the low DO acclimated groups has higher IGF gene expression rather than other groups. However, the difference in the gene expression is not significant.
So, in summary, we can decipher this as the HSP70 trend was a general stress response, but those lower in the acclimated groups, and maybe this acclimation could have an impact on organisms in the wild. If they were able to acclimate, then when that stress became more significant, they might be able to adapt to like different secondary stressors like disease or increases in temperature. And again, the lower levels tended to be associated with the lower DO acclimated individuals, which Abby mentioned that if they're able to accommodate the hypoxic conditions more readily than the organisms that it's just a sudden exposure, they might have better chances of survival. As we mentioned before, none of it was significant because there appeared to be a lot of individual variations among individuals and between the groups, which could be just an inherent response of the oyster to hypoxia exposure, or it could be one of an artifact of the DO treatment actually fluctuated from 1 to 2 milligrams per liter pretty much each day because the mechanism for the nitrogen and oxygen tanks weren't really that great. But in general, we did see that trend.
And in the IGF gene expression, we saw the high levels of IGF gene expression in low DO acclimated group. It can be caused because the low DO acclimated group is more adapted to hypoxic environment rather than the other groups, and so they can allocate energy better for survival and can save some for growth, but the other groups cannot, well, because they're not acclimated. But however, the insignificant results that we got can be caused by the low number of samples that we use, and higher number of samples can give us more accurate data and more significant results.
And it should be also noted in general that this is all mRNA expression, not protein expression, so it doesn't necessarily mean that there were active factors involved. This is just simply a proxy that's very commonly used, but there could be the possibility that this isn't representative of an actual acclimation event. Right? We tried doing the protein with the Western blot. Very well. So why is this important? We are noticing that hypoxia is becoming more common, especially in environments like now. If we can understand how organisms are able to acclimate and adapt, increase their chances of growing and surviving, this might have implications for commercial shellfish industry and also conservation of species. Thank you.